And welcome back, y'all. All right, heading to the finish line, toward it at least. I'm going to ask you to pause. I would like you to complete the mild number 1 part on the back. I want you to simplify all those, rewriting them in simplest form. Pause your video and come on back when you're ready. The most challenging part here was probably the square root of 20, which is the same or equivalent to 2 times the square root of 5. Now, yeah, I'm going to leave it as that. Let's go ahead, pause your video, attempt mild number 2, and come up back to check answers in a moment. So let's go ahead and walk through a couple of these, folks, as you see these answers. I'd like to start with square root of 18. Square root of 18 could be rewritten if we were to split 18 down into its prime factors of 2 times 3 times 3. Now, remembering that if there's no index, it means a square root. Is there any number multiplied by itself? You could say absolutely. So we can rewrite that as 3 times the square root of 2. All those are equivalent expressions, but this one at the end is what we would call simplest form. That is one ugly smiley face. Meanwhile, how about the 4th root of 48? So this one I don't have off the top of my brain, so I'm going to come off to the side, whether you do a factor tree or upside down division. Let's go ahead and break this down to its prime factors. There's a whole lot of 2's here. And finally we get to the end, so we can break 48 down into the product of 2 times 2 times 2 times 2 times 3, which leaves us asking ourselves, well, is there anything multiplied by itself 4 times? And the answer is yes. So we can pull that 2 out, but unfortunately 3 is going to stay in the radicand, so we should finally have 2 times the product, 2 times the 4th root of 3. Now, let's make things a little more interesting, shall we? And complete the medium number 1 together. So I'm going to go ahead and rewrite the square root of 12x squared y as a product of its prime factors, 2 times 3 times x times y. Looking, because our index is 2, for any number multiplied by itself twice, which means we can pull out a 2 and an x, but unfortunately 3 and y have no partners, if you will. So we're going to have to leave those inside, leaving us with 2x times the square root of 3y as simplest form. Onward we go, where 200 is the product of 2 times 100, 100 is 2 times 50, 50 is 2 times 25, and 25 is 5 times 5. And then z to the 6th is z multiplied by itself 6 times. Again, a second or square root. I see 2 times itself, I see 5 times itself, and I guess I could do this. Z to the 3rd times z to the 3rd. Now note what gets pulled out here. Both the 2 as well as the 5 with the single 2 left over. And then a z to the 3rd times another z to the 3rd. But if we're going to write this in simplest form, let's go ahead and multiply the coefficients. 2 times 5 is 10. Z to the 3rd, all multiplied by the square root of 2. I'm trying to make that look like it's not a z. And let's finish up with the 3rd root of 16k to the 7th. So if we break that down, 16 is the product of 4 and 4, which is furthermore broken down in the product of 2 times 2 times 2 times 2. Multiplied by k by itself repeatedly. Pulling a 3 out of this, I see 2 times 2 times 2, so I'm seeing those with a 2 left over. Now this is interesting. We have k squared times another k squared times another k squared. So if we were to pull out the factors that are able to be pulled out, we're going to have 2 times 2 times 2, so a single 2, k squared times itself repeatedly. But we're still going to have the 3rd root of 2k left over. Now, interesting, they all do seem to have a product with some quantity outside, something that could be pulled out in a pretty fashion, as well as they're still going to have some kind of leftovers inside. Now, go ahead and pause your video. Let's see how you do with medium number 2 and come on back when you are ready. I did embed one mistake in here. I'm going to let you see if you can spot it. Rewind the video if you need, rewatch what you need, but otherwise I would like to invite you, if you're interested, to hit up the spicy stuff. Now ideally this would be done in groups in class, but let me invite you if you want. Pause your video, see if you can do a few of these. Come on back when you're ready. All right, let's start with the right side, where almost all of them are answers. The only one that do not line up, A, would have a 4 in the numerator, but that definitely is not in the numerator, and it is not 12. Meanwhile, B, C, D seem rather obvious if you look at the work off to the side. And E is actually true as well. Anytime you have a negative exponent, flip it to its reciprocal. So the 1 goes down below, the 16 goes up top, but once you flip it to its reciprocal, that exponent becomes a positive, so E works out, and G does as well. Meanwhile, the 4th root of 81, tens, hundreds, thousands, 10,000 is going to be 3/10. This one I didn't put any work for, but if you have a question, come on when you're ready. And I found this last one to be really interesting. So remembering, please, that when we are dividing powers with the same base, you can simply subtract the exponents. Finding that common denominator would lead us to x to the negative 2/21, which means we can put the numerator as the exponent and the denominator as the index. Now, we don't want to leave anything when possible. We don't want to leave anything when possible as a negative root. So what can we do here other than deal with a spastic computer? We can put x over 1. We can now flip it to its reciprocal. Instead of x over 1, make 1 over x. And then it becomes x to the 2nd power. That was a spicy problem. I probably would call that one of the more higher level SAT level problems. All right, folks, that's what we have for today. Take care, do well, let's grow. Let me know if you have any questions when you return to class. See ya.